Picture the sun disappearing. Not exploding, not collapsing, just vanishing, gone, erased from the universe, as if it never existed. What happens after that? Most folks have a general idea. Everything turns dark. The solar system breaks apart. Earth floats off into interstellar space. Life finishes. All of that is correct, but the specifics, the exact sequence of events, what occurs first, what occurs second, what the physics actually demands in each passing second and minute and hour are much more interesting and much more revealing than the basic story. Because this thought experiment is not simply an exercise in disaster exploration, it's a gateway into the deepest structure of physics, into how information moves, into the difference between Newtonian and Einsteinian gravity, into what we mean when we say something is actual, into the speed of causality itself. Before we begin, what does disappear mean? In the actual universe, as we can know it, the sun cannot just vanish. Energy is preserved. Mass is preserved. Information is preserved. The sun is 4 times 10 to the 30th kilograms of mainly hydrogen and helium plasma. That mass energy cannot just cease to exist. It would break every conservation law we know. So, this is a thought experiment. We're questioning if by some hypothetical mechanism we don't grasp the sun were eliminated from spacetime at this instant. If it just ceased to exist at time zero, what would physics require for the following minutes and hours and days? For precisely 8 minutes and 20 seconds after the sun disappears, nothing on Earth transforms. Nothing. The sky is still brilliant. The day goes on exactly as it was. Birds chirp. Traffic flows. Crops develop. Your skin is still heated from sunlight. The photons currently covering the Earth are still reaching us, still bringing their energy, still making the day. This is not a poetic declaration. It is a direct result of the finite speed of light. Light moves at 300,000 kilometers per second. The sun is roughly 150 million kilometers from Earth, one astronomical unit. Dividing distance by speed, 150 million divided by 300,000 equals 500 seconds, 8 minutes and 20 seconds. The final photons released by the sun, at the instant it disappears, are already in motion. They departed the sun's surface and started their journey through space at time zero. For 8 minutes and 20 seconds, those photons move toward Earth. They reach us. They heat the ground. They drive photosynthesis. They enter your eyes and produce the feeling of a normal day. And then they cease. But here's what makes this 8-minute period so remarkable from a physics perspective. It's not only light that takes 8 minutes. Everything takes 8 minutes, because nothing, no information, no physical influence of any type can move faster than light. This is not a technological restriction. It's the structure of spacetime. The speed of light is not only the speed of electromagnetic radiation, it's the maximum speed of causality itself. What about gravity? Here is where this thought experiment turns genuinely profound, and here is where Newton and Einstein separate dramatically. In Newtonian gravity, force is immediate. Newton's law states the gravitational force on Earth relies on the sun's mass and the Earth-sun distance. Right now, the instant the sun disappears in Newton's theory, Earth's gravitational link to the sun is immediately broken. Earth's orbit is immediately disrupted. At time 0 + 1 nanosecond, Earth is already flying off in a straight path. This is one of the reasons Newton's theory is incorrect. In Einstein's general relativity, gravity is not a force. It's the bending of spacetime, and spacetime bending spreads at the speed of light as gravitational waves. When the sun vanishes, the spacetime bending it was keeping. The curved geometry that holds Earth in its orbit doesn't disappear immediately. The information of the sun's disappearance must move outward through spacetime as a pulse of gravitational radiation, a gravitational wave. This wave travels at precisely the speed of light, 300,000 kilometers per second. Therefore, for precisely 8 minutes and 20 seconds after the sun disappears, Earth keeps orbiting exactly as if the sun was still present. This is remarkable. Earth orbits a gravitational source that no longer exists. The space-time bend in keeping Earth's orbit is actual. It's creating actual centripetal acceleration on the Earth. But the sun that produced that bending is absent. Earth is orbiting a phantom, a memory in the geometry of space. This result shows something deep about what gravity truly is. In Newtonian physics, gravity is a force between objects. If the source object disappears, the force disappears. In general relativity, gravity is a geometric characteristic of space. The space-time bending exists separately from the source. It requires time for the bending to settle after the source is taken away. At the instant the sun disappears, a gravitational wave, more accurately, a complex pulse of spacetime bending starts spreading outward from where the sun was. This is not the periodic gravitational waves we observe from binary black hole mergers. Those are sinusoidal. This is a step function in spacetime bending. A pulse, as it travels through space, it marks the shift between sun-curved spacetime and flat spacetime. Before the pulse, spacetime is curved by the sun. After the pulse travels by, that bending is absent. The wave expands outward at the speed of light, a sphere of shift, expanding at 300,000 kilometers per second. At 10 seconds after the sun vanishes, this gravitational wave is 3 million kilometers from where the sun was. That's roughly 4% of the Earth's distance. The innermost areas of the solar system, the space very near to where Mercury orbits, are just starting to get the information. The geometry of spacetime is already shifting in those inner areas. But for us, 8 light-minutes distant, nothing has shifted yet. Mercury, the nearest planet to the sun, orbits at an average of roughly 58 million kilometers. Light requires about 3 minutes and 13 seconds to move from where the sun was to Mercury. 1 minute after the sun vanishes, the gravitational pulse has moved 18 million kilometers. It's still distant from any planet, but something different is occurring that almost nobody mentions in these conversations. Neutrinos. The sun is a huge producer of neutrinos. In the core of the sun, where hydrogen combines into helium, hundreds of trillions of neutrinos are created every second. These neutrinos almost never interact with matter. They flow freely through the sun's interior, which requires them about 2 seconds to cross, then out into space. At any instant, roughly 65 billion solar neutrinos are traveling through every square centimeter of your body every second. You are soaked in them constantly. At time zero, the solar core vanishes. The neutrino source disappears. But just like photons, the final neutrinos released by the sun at time zero are already in motion. Here's an interesting detail. Neutrinos move at very near to, but not precisely the speed of light. They have a small mass. We know this because different neutrino types oscillate between varieties, which needs mass. This mass means they move infinitesimally slower than light. For practical reasons, this difference is tiny. 3 minutes and 13 seconds. After the sun vanishes, the gravitational pulse arrives at Mercury. The light travel time from Sun to Mercury is 3 minutes and 13 seconds. The gravitational travel time is also 3 minutes and 13 seconds. They're the identical speed, so the optical and gravitational information arrive at Mercury at the same time. At precisely 3 minutes and 13 seconds, 2 things occur to Mercury at the same instant. The final sunlight reaches, and the space-time bending changes. Mercury turns simultaneously dark and free. From this instant, Mercury is no longer in orbit. It's moving in a straight path at its orbital velocity, roughly 47 kilometers per second, tangent to its previous orbit. 8 minutes and 20 seconds after the sun vanishes, the gravitational pulse reaches Earth's orbit. At this precise instant, 2 things occur at the same time that transform everything. First, the final photons from the sun reach us. The sky turns dark, not immediately. Different sections of the sky still display light from stars, but the brilliant sun, which was just present, is absent. The day side of Earth shifts from full daylight to night. In an instant, from 1360 watts per square meter of solar radiance to 0. The temperature effects require longer. The atmosphere and oceans have thermal mass and won't cool right away, but the direct solar radiation ceases. Second, Earth's orbit is broken. The spacetime bending keeping Earth's orbit is replaced by flat spacetime as the gravitational pulse travels by. Earth is now traveling in a straight path at its orbital velocity, roughly 30 kilometers per second tangent to its previous orbit. Earth at this instant becomes an unbound object. It will never go back to its previous orbit. It's not thrown outward forcefully. There's no blast. It just keeps traveling in the direction it was moving with no centripetal force to bend its path. It travels in a straight path into interstellar space. When the gravitational wave pulse travels by Earth and the bending changes, does Earth shake? Does it feel a sudden shift? This is a fascinating question. In general relativity, gravitational waves are transverse waves. They stretch and squeeze space, perpendicular to their direction of movement. As the pulse travels by Earth would briefly feel tidal forces, different sections of Earth being stretched and squeezed relative to each other. For the first hour after the sun vanishes, from Earth's view, the results are harsh but still survivable. The Earth's surface starts to cool, but the atmosphere and oceans are huge thermal reserves. The atmosphere with its greenhouse gases will hold the existing heat. The oceans will require months, 2 years to freeze. Notably, in the first hour, average global temperature falls by maybe a degree or two, uncomfortably, but not deadly. The immediate threat is not cold. It's darkness. Complete darkness on the day side is instant at minute 8. But cities have power systems. Buildings have heating. Nuclear power plants don't require sunlight. Photosynthesis halts right away. Plants don't die right away. They have energy stores, but the process of energy creation from sunlight is finished. The complete food chain, which finally relies on photosynthesis, starts a slow terminal fall. Animals that rely on daylight for behavior, for hunting, navigation, reproduction, are right away disrupted. The planet goes into a permanent night. Within a week of the sun's disappearance, the gravitational pulse has arrived at the outer planets. Jupiter, at 5 astronomical units from the Sun, gets the gravitational information in roughly 42 minutes. Saturn, at 10 astronomical units, in roughly 83 minutes. Each planet, when the pulse reaches, turns from orbiting to traveling in a straight path. The solar system literally breaks apart. 8 planets, dozens of moons, billions of asteroids and comets, all of them moving off in random straight-path trajectories into interstellar space. A month after the sun vanishes, the surface of the Earth has cooled severely. Average global surface temperature roughly minus 20 degrees Celsius. This is beneath the freezing point of water across most of the planet. Snow and ice are creating at unprecedented rates. But here's something amazing that might give life a battling chance. Geothermal heat. The Earth's interior is heated. Incredibly heated. The core is roughly 5,000 degrees Celsius. As heated as the surface of the sun. This heat originates from 2 sources: leftover heat from the Earth's creation 4.5 billion years ago, and continuing radioactive decay of isotopes like uranium-238, thorium-232, and potassium around hydrothermal vents, both in the ocean and on land. Geothermal heat is much greater. These are locations where Earth's internal heat arrives at the surface directly, and around these vents, life might survive forever. A year after the sun's disappearance, the world is almost unrecognizable. The surface is frozen. Average temperatures are roughly minus 60 degrees Celsius. Ice covers all of the oceans. In 1,000 years, Earth has arrived at a new balance. The surface temperature is roughly minus 240 degrees Celsius, within 30 degrees of absolute zero. Most of the atmosphere has frozen and fallen, but the deep ocean near hydrothermal vents is heated, maybe 10 degrees Celsius. Liquid water. Energy from the Earth's interior, and if microbial life survived, which it probably would, ecosystems exist around these vents. We understand that hydrothermal vent ecosystems on Earth today are completely independent of sunlight. They operate on chemosynthesis, chemical energy from the vent fluids, rather than photosynthesis. Let me step away and tell you what this thought experiment truly shows about the laws of physics. Information, any information, gravitational or electromagnetic or any other type, moves at most at the speed of light. This is not only about light, it's about the maximum rate at which cause can come before effect. The 8-minute delay is not an inconvenience. It's a basic characteristic of space. The fact that Earth keeps orbiting for 8 minutes after the sun disappears, orbiting a gravitational source that no longer exists, is only possible because gravity is space-time bending. This thought experiment has a philosophical side that is as interesting as the physics. It shows with clarity what it means for information to move at a finite speed. Right now, you are observing the universe As it was, not as it is. The stars you observe at night are not where they are now. They're where they were years, decades, centuries, millennia ago. The sun you observe is 8 minutes old. The moon is a bit over a second old. This is not a restriction of our telescopes. It's a basic characteristic of physics. You can never observe the universe as it is right now. You can only observe it as it was with the time delay determined by distance and the speed of light. The sun disappearing thought experiment makes this actual. For 8 minutes, you would be sitting in sunlight, heated and lit, with no knowledge that the source of that light and warmth had stopped existing. You would be living in a world that was already finished. And that's not hypothetical. That's the situation you're always in, to different degrees. The universe around you is always a picture of the past, not the present. Life is remarkably strong. It has survived every mass extinction in Earth's history. Without the sun, surface life finishes. That's nearly sure. Bat deep life, life around hydrothermal vents, microbial life in deep rock. This might survive basically forever. Geothermal heat will keep going for billions of years. The radioactive decay driving Earth's interior is separate from the sun. As long as that decay keeps going, Earth will have internal heat. Life will continue. 8 minutes. That's how long it requires for the information to reach. For 8 minutes, you would live in a world that had already finished, in sunlight from a source that no longer existed, in the gravitational hold of a star that had disappeared. Those 8 minutes would teach you something deep. Causality is finite. Information moves at the speed of light. The universe you experience is always the universe as it was, not as it is. The sun would be absent, but its light would still heat you. Its gravity would still hold you for 8 remarkable, deeply revealing minutes. And then the information would reach, and everything would transform.